step here in the list is to isolate the squared variable or the squared quantity. Well, in this first problem, that step is already done. So that x squared is already by itself. We don't have anything extra that we might need to move or get rid of. And so we are ready to move on to the second step, and that is to square root both sides. So that's going to look like this. And it's just like when we have done other things with solving equations, like if you add 5 to both sides, if you divide both sides by 2, you can do that with a square root. If you square root the left side, just also square root the right side. Now the left side, the square root of x squared is just x. It's actually just undoing the squared. And if you think about this with a number, like if you have a number and you square it, and then you take the square root of it, you just get back to where you started. Now on the other side, there's one extra little piece that we need to think about. When we're doing the square root of 16, in your head you might be thinking, well that's just 4, because 4 squared is 16, but there's actually 2 square roots for 16. It could be both positive 4 and also negative 4. And so the way that we're going to indicate that 2 answers is with a symbol called the plus or minus symbol. And it looks like a plus sign with a little minus sign right underneath it. So that's really the quickest, fastest way to represent that we have 2 different answers here, both positive 4 and negative 4. Now, if you think about checking it in the equation, 4 squared is 16, so that works. Negative 4 squared means negative 4 times negative 4, so that's also 16, so that's why we have these 2 answers. HOC, let me tell you your speeds. Okay, so you have 32, and then go ahead and grab a packet right up here. All right, now in Math Excel, I do want you to know that we're not actually going to type it in with that plus or minus sign. You can certainly write it that way on your paper, but the way that this is going to look, there's actually 2 possibilities for how you would type in your answer. So one is that we would just separate our answers with a comma. So it'll say x equals, and then there will be a box for us to type in our values. So it might look like this, 4, comma, negative 4. So that's a different way of saying the same thing. Another way that it might look on Math Excel for your 2 answers is it has these squiggly brackets already in there for you, and very similar on the inside, you would put in your 2 different answers, just separating them with a comma. All right, so those will be our solutions for our first equation. Let's take a look now at the one in the middle. So this one has a little bit more going on. So here we have 4x squared minus 20 equals 0. So this is where we do need to do that first step of isolating the squared piece. So that x squared, I'm going to highlight that, and we want to get that by itself. So we need to get rid of that minus 20 at the end. We also need to undo or get rid of the 4 that's being multiplied in front. What can we do to both sides to get rid of this minus 20? Or how can we move that to the other side? Yeah, let's add 20 to both sides. All right, so that's going to give us this. We have 4x squared equals 20. All right, what can we do now to both sides to get rid of that 4 in front of the x squared? Perfect. All right, so now we finally have this x squared quantity isolated. We've got it all by itself, so we're done with the first step. Now let's look at the second step. So that's similar to what we saw in the first problem. We're going to put the square root symbol on both sides. We're going to put the plus or minus sign in front of the number part. You never need to put the plus or minus sign in front of the x, only the number. So that's going to look like this, square root the left side and square root the right side. So the square root of x squared, just as we saw before, that's just x. On the other side, we're going to put our plus or minus symbol, but we can't actually do the square root of 5, not perfectly anyway. If you were to type it into your calculator, you would get a decimal. It's approximately 2.23. But we're not going to be using decimals in this unit. We actually want to keep everything in exact form, which just means you're going to keep the square root symbol in your answer. So it's just going to be right after that plus or minus sign that we already put. It's going to be plus or minus square root 5. And in Math Excel, there's the little tools at the bottom. There's a square root symbol on a little math equation kind of keypad. You're going to press the square root symbol to get that type of answer to show up. Same thing as before. You can say positive square root 5 and then put a comma and then put a negative square root 5. All right, now the last equation here is a little bit different because now it's not just a single x that's being squared, it's a whole quantity that's being squared. A quantity is what we say something that's inside of parentheses. So we have x plus 1 and then it's that whole thing that's being squared. Notice how the square is on the outside. Well, we're still going to continue in the same way of taking the square roots of both sides. And all that's going to happen on the left is that square root symbol is going to cancel out the squared symbol. And so what's going to come down is x plus 1. So it's just going to undo that squared that was there on the outside. Now over here on the other side, what could we say here for the square root of 9? Yeah, we can actually do that one. So we're going to write it as a 3. Don't forget the plus or minus sign in front, indicating that we actually have 2 square roots. Now, we haven't talked yet about this third step because we didn't need to, but this is now the problem where we have to go one more step of solving for x. So we're not done yet. We want to actually get x by itself, but we need to notice here that this is going to split us into 2 separate situations. So either x plus 1 could be positive 3, or x plus 1 could be negative 3. So we're going to go ahead and split it to show these 2 possibilities. And then we're going to solve each one separately. So we can do that by subtracting 1 from both sides. So on this side over here, we end up getting that x equals 2. Over here on the other side, when we subtract 1 from both sides, we get our other solution to be negative 4. So notice that sometimes our solutions are just 2 completely different numbers. It's not always like positive 3 and negative 3 if we have to do that final step of solving for x. Okay, so let's make a little connection here with our homework for tonight. So the first 2 examples that we just did, those are really similar to Math Excel number 1 and number 2. And then this one over here is really similar to Math Excel number 3. So let's write that down off to the side. So again, when you're looking back at your notes, you know exactly which problems. We're just kind of going in order from the way that they're listed in the homework. So each of the equations that we've looked at so far were solved using a square root. Well, in order for us to use the square root, we had to have either an x that was being squared or a quantity, a parenthesis, that was being squared. And so notice that this next equation looks very different. So here we have x squared plus 12x plus 36 equals 4. And it's asking us here if we can square root that in its current form. And the answer is no, because on this left-hand side, we have a couple issues here. Anytime you are just simply adding terms together or subtracting them, we can't just take the square root of the whole thing. Even if the individual pieces were all perfect squares, it just doesn't work that way in algebra. The only time that you can square root something that has a plus sign or a minus sign is if it looks like this previous one did. The plus or minus sign has to be inside of a parentheses where the whole thing is being squared on the outside. So we don't square root individual pieces. But also, even though 36 is a square number, like we can't take the square root of 12x. That would be like very cumbersome to do. And so if we see something that looks like that, we need to know that we're not able to use the square root method, at least not yet. And so what we're going to take a look here in part B is a way that we can actually rewrite that equation so that we can be able to square root it. We're actually going to rewrite it into something that looks like this one so that we can do the square root of both sides. So what's special about this x squared plus 12x plus 36, that's actually a special trinomial. It's a perfect square trinomial. And so we can factor that into something that looks like this, a quantity in parentheses that's being squared. If we make it look like this, then we can use the square root method. And so let's talk about a couple of ways that we can factor that x squared plus 12x plus 36. Since it's a basic trinomial, we could actually go back and think about two numbers that multiply to 36 and also add to 12. Now the thing about these perfect square trinomials is that whatever these numbers are on the side, in order for it to turn into this, it has to be the same number. Can you think of two numbers here that would work? Let's do 6. 6 and 6. So 6 times 6 is 36. 6 plus 6 is 12. So really that would be x plus 6 times x plus 6. But because it's being multiplied by itself, we can just write it as the quantity x plus 6 squared. Another way that you can think about getting this factored is going over here to this rectangular box and taking the pieces that are highlighted in yellow and filling them on the inside little squares. So the x squared is always going to go up here in the upper left corner. The number at the end, the 36 in this case, is always going to go down in the lower right corner. And then we need to think about the middle term here. So that 12x in the middle, we just have one term, but we have two sections here to still fill in. Well, those two sections are exactly the same size. So what we want to do is take the 12x and divide it perfectly in half. So 12x divided by 2 gives us like two sections of 6x, right? So 6x plus 6x is still equal to 12x. So we're going to be filling in the squares. And then it's like the box method working backwards. So when we think about, okay, what was being multiplied together to make x squared, well, that would be a little side length of x on the top, and it'd be another side length of x on the side. If we think about like the 36 at the bottom, that would have to be a side length right here of 6, and then another side length right there of 6. And notice how that also works to make the two little sections of 6x. The 6x's are both positive because we don't have a negative sign in front, so we can actually put a plus sign in front of the 6 on either side. And so now looking at the way that we filled in the edges, that's x plus 6 times x plus 6. So that would be another way of getting to the same factored form. But also, because it's a square, it's just being multiplied by itself, so it's really x plus 6 squared. The last way that you can do this, if you recognize that you have a perfect square trinomial, is to write your parentheses being squared, square root the first term and list it first, square root the last term and list it second, and then look at the symbol in front of the middle term. That's what's going to tell us what symbol goes in between them, meaning like a plus sign or a minus sign. So this process here of turning a perfect square trinomial into something that looks like this is going to be an important step of being able to use the square root method, because now we can take the square root of both sides. So I'm going to pause here and give you a few minutes. I want you to finish solving this equation. And again, we've turned it into something very similar to this one. So you can look back at what we did in the previous problem. I want to see if you can finish solving that all the way down, getting your two separate answers for x. All right, so let's come back together here to check in. So when we square root both sides, that next step is going to look like this. We're just putting the square root symbol over each piece. Now on the left, that square root symbol is going to undo the squares. So the only thing that we're left with is x plus 6. On the other side, the square root of 4 is 2, yes, but it could be positive 2 or it could be negative 2. So we're going to put that plus or minus sign to represent those two possibilities. Now, in solving for x, there's two equations that we're going to write. So either x plus 6 could be 2, or x plus 6 could be negative 2. And so when we subtract 6 from both sides, we get two answers. X could be negative 4, or x could be negative 8. All right, so let's take a look at the next piece. So it says here, well, what if our expression doesn't factor into a perfect square trinomial? So let's say that we have something like x squared plus 6x on one side, and we want to figure out what special number we would have to add to the end to make it a perfect square trinomial, so that we could factor it into something that looks like this. So this is the key, is to get it here so that it's being squared so that we can take the square root of it. So I'm going to show you this first. I'm going to show you two ways that you can figure out the number on the end. I'm going to start over here with that rectangle diagram because we know some pieces, but we have to figure out a missing piece. So we can still start the same way of putting the x squared piece up here in the upper left corner. Now, when we look at the 6x here in the middle, we know that that's going to be divided in half to go into those two little sections there on the side. What's half of 6x? 3x. So let's fill this in here. So we have to divide that in half to figure out the 3x and the 3x. So the piece that we don't know, that the number at the end here that's missing, is what would be in that lower right-hand box. Well, if we just think about working backwards with how this is already filled in, we can actually start to fill in our side lengths. So for example, this top side length here would be x. This little side length here on the side would also be x, because x times x equals x squared. What would we fill in this next side length right here? It'd be a 3, yeah, because it has to make 3x. So we have an x over here on that side. What do we multiply x by to get 3x? All right, down here is exactly the same thing, so we're going to fill in a 3 as well. Now, in between the x and the 3, do you think that we would put in a plus sign here, or would we put in a minus sign? Plus signs, yeah, they're positive. We don't see a negative sign. So it's really looking like it's x plus 3 times x plus 3. So now, looking at the way that these are labeled, how would we fill in the missing piece? Yeah, now it's just 3 times 3, so it's 9. And so the process that we just did to figure out what that number was on the end, we call it completing the square. Because in our little diagram here, we literally were trying to figure out what is the number to complete the square. We want to make it a fully completed square that's all filled in. So we had to put a 9 in that position. Because it was x plus 3 times x plus 3, let's also write here that if we were to factor it, it just turns into the quantity x plus 3 squared. Okay, so that is one way that you can figure out the missing number when you're completing the square. Put it into your box. A second way that you can do this, maybe a faster way, it doesn't require you to draw a box every time, is to use a little diagram involving arrows. We're going to start here in the middle, and underneath the 6, in the middle here, underneath the 6x, I'm going to do a little arrow pointing down, and I'm going to take just the 6 part, so no x here, just 6, and we're going to divide it by 2. So that kind of represents when we divided it in half to get it into the two separate sections. And then when we get that result, so I'm going to put some big parentheses around the outside, we're going to square it. Over here, I'm going to make a little arrow going to the right. 6 divided by 2 is 3. And then I'm going to do a little arrow going up to that empty space, showing our final answer of 9. 3 squared is 9. When we go to factor it, we know that it's going to be a quantity in parentheses that's being squared. Remember that we could just square root the first term and list it first, square root the last term and list it second. Look at the symbol of the middle term. That's the symbol that's going to go in between. So that process is called completing the square, and that is a skill that we're going to use to solve a few more equations. So let's go ahead and turn your paper over to the back. All right, so before we solve some equations with this, we're going to actually practice a few more scenarios of completing the square, meaning we're going to figure out what's this missing number that we would need to fill into the end so that we turn it into a perfect square trinomial. So similar to the one that we looked at on the other side, I want us to do one more of these here together because this one now has a minus sign in front of the middle term, so we're going to see how it's going to work a little different. So we have x squared minus 14x. Again, you can think about using that box method. I'm going to show the method again of using the arrows. So underneath the negative 14, I'm going to put a little arrow pointing straight down, and I'm going to rewrite negative 14. Then I'm going to divide it by 2, and then I'm going to take that result, and it's going to be squared. Whatever that number is in the middle, we're always dividing by 2 every time. You're always squaring it every time. The only thing that could be different is the numerator. The numerator is just going to match whatever you have in your equation. What's negative 14 divided by 2? Yeah, and let's, just for the sake of keeping it consistent with the sign, let's keep it as a negative 7. It actually doesn't matter, though, because it's still going to be a positive answer. 7 squared is the same answer as negative 7 squared. What is 7 squared? 49. All right, so we're going to fill in a 49 at the end. So we just completed the square because we figured out that we need to have a 49 so that it can be factored into something that looks like this. So to do the final step of this, it's always going to have the same format. So it's just going to be a single parenthesis with a squared on the outside. And I'm going to think about this method. So I'm just going to square root the first term and put it first. I'm going to square root the last term and put it second. Now the only difference on this one is because we have a minus sign in front of the middle term, we're going to put a minus sign down here below. So the two things that we're doing is we're figuring out what number goes in the blank, and then we're going to go ahead and factor it. So let's take a few minutes here. All right, so always the middle number divided by 2 squared. So the next one here, we're adding the 25 onto the end, so it's going to factor into the quantity x plus 5 squared. Notice that the number that we're adding onto the end is always positive, because it's always the result of squaring something. So that's interesting. But again, if the middle term is being subtracted, we are going to have a subtraction sign. Oh, hold on, what did I mess up? All right, so that last one ends up being the quantity x minus 4 squared. Perfect. So now we actually have all of the pieces to be able to do our last and final method. And by the way, this little piece that we did here of just figuring out what number gets added onto the end, this is going to be very similar to the next two questions on Math Excel. So let's write this down. This is like Math Excel number 5 and Math Excel number 6. And you have to take a close look at what the directions are asking you to do. I think on Math Excel, I don't think it's going to have you factor it all the way. I think the only thing you're typing in is just what's the number that needs to be added onto the end. But take a close look at what the directions are asking. All right, so now we're going to put all the pieces together. We're going to apply the skill of completing the square to solving an equation like this one. So let's look at what we have here at the start. So we have x squared plus 6x equals 7 on the other side. We're going to take a look at a list of steps down here below as we apply them to the equation. Now, it's helpful to know right at the start here that the completing the square method is useful for anything that looks like this originally. And so notice that ours is actually not set equal to 0. If we wanted it to equal 0, what it would have looked like before would be x squared plus 6x minus 7 equals 0, so we would have to subtract 7 from both sides to get it to look like this. All right, so the very first step here is to move c over to the other side of your equation. Or here it says move c to the right-hand side. Well, in our problem, it's like c would have started out being negative 7. Well, when we move that to the other side, it's going to turn into a positive 7. So that step was actually already done for us. Sometimes you'll have to do it, sometimes it might already be there. So the step 1 is good. Step 2 is something that you actually will not need to worry about when you are solving these. But I want you to know, in the world of solving quadratic equations, if you had a number in front of the x squared other than 1, so if a was not 1, we would have to divide everything on both sides by a before we would be able to complete the square. Now, the ones that we are going to be doing will always have a equaling 1. So you won't have to worry about that second step, but that's what it would be if there was another number in front. Okay, so now let's take a look at part 3. This is where we are going to complete the square. And before we actually do that, I want you to rewrite this, leaving some open space before the equal sign. So I want you to have some open space right here so that we have some room to write the special number when we complete the square on the edge. So we're going to give ourselves some space. And the way that we're going to complete the square is just what we did at the top of our paper. So we're going to do the middle number, that's called b, in this case that is 6. 6 divided by 2 squared. So that's really 3 squared. And that's going to result in adding a 9 at the end. Now, I want you to also put a box around the plus 9, just like I did here, because I want this to stand out on your paper that you just introduced something brand new into this equation. You added 9 to the left. But it is still an equation. We need to keep our equation balanced. If you think about what we had in blue as a balanced scale, it was balanced out. Well, then it's like we just added 9 gold coins to the left, so now it's not balanced. So what could we do to the other side to get it back to being level? We also have to add 9 to the other side. Yes, whatever we do to one side, if there's something brand new that you add in, you have to do that to the other side. And that's why I like to put that little box around it. This step right here is the easiest thing to forget when you're solving these equations. This is the most common mistake I see students make, is they'll complete the square, they add 9 to one side, but they forget to add it to the other side. We're just going to be super aware of that. So in our steps down here, we're going to do b divided by 2 squared. We already did that. And we are going to add it not just to one side, but we're adding it to both sides. So that's what step 3 is telling us to do. Okay, so now that we've completed the square, now it is time for us to factor. So on the left side here, the whole point of completing the square, of figuring out the 9 gets added onto the end, and so that we can factor it into a parenthesis that's being squared. So you could write that as a little template every time. What we're going to fill in this time is we're going to do the square root of x squared. So we're going to have an x in front. We're going to do the square root of 9 at the end, so we're going to have 3 at the end. And here we're going to see that the middle term is being added, so it's going to be a plus sign. Now, on the other side, we still have to add those pieces together. It's going to be easier because it's just going to be 2 numbers, But we are going to do 7 plus 9, and we're going to turn that into a 16. So now, really, everything that we did, so we factored, hold on a second, let's look at step 4. We're going to factor the left side into either x plus b over 2 squared or x minus b over 2 squared. B over 2, that's just what we had right here, like right before we squared it. So notice how that's the same as the number that we have in our parentheses. All right, now we are ready to do the square root method. So we're going to finish up here with step 5, which is just to square root both sides. I had to rewrite mine over here because I ran out of space. But now this is just like the problems that we were doing earlier. So let's go ahead and do the square root on both sides. So on the left side, it's just going to get rid of the squared symbol, and we have x plus 3. On the other side, when you square root 16, it's either positive 4 or negative 4. Then we're going to split it into these two possibilities. X plus 3 equals 4, or x plus 3 could be negative 4. All right, then we're just going to subtract 3 from both sides in both of our equations. We get our two final answers here. So this is step 6 here, solving for x. We end up getting that x is positive 1. On the other side, we get that x is negative 7. All right, and this one is a little different, again, because of that square root symbol. So the first thing we want to do is move c to the other side. So right now, c is negative 1. We're going to do that by adding 1 to both sides. So we want to make sure we have a positive 1. Notice that when I moved it over, I still left a little bit of space before the equal sign. All right, then we're going to complete the square. So it's going to be 12 divided by 2 squared. And that simplifies to be 6 squared. And that ends up being 36. If we add, sometimes I circle it. Sometimes I put a square. This time I circled it. If you add 36 to one side, we also have to add 36 to the other side. So remember, that's a part that can be easy to forget. All right, so now we're going to go ahead and factor this. It's going to factor into the quantity x plus 6 squared. So the square root of x squared is x. Square root of 36 is 6. It's being added. Now on the other side, 1 plus 36 is 37. Okay, so now we're ready to do the square root method. When we square root both sides, we get x plus 6 equals, plus or minus, square root of 37. We can't do the square root of 37 perfectly, and we don't want a decimal, so I just want you to leave the square root symbol in your answer. So all we need to do to get x by itself is we need to subtract 6 from both sides. Now you could do a minus 6 on the end of the square root part, but what is more common is that people actually put the minus 6 in front of the square root part. So this would be our final answer. Now, if we were doing this in Math Excel, this is how you would split it up. So you would write negative 6 plus square root 37, and then do a comma, and then you would do negative 6 minus the square root of 37.